So let me review that thing and then we will go ahead and try to finish this code. So what we are trying to see, so just you can see this is the structure that we are working with. The structure is defined from line 4 to line 8. So it has a key and it has the key is of type integer. It can be, like for example, let's say if the key has to be an Aadhaar card ID, what should be the data type? If the key is an Aadhaar card, then what should be the data type of the key? Yeah, perhaps unsigned long might be a good, it may work, unsigned long may work, Aadhaar card. And what does line 10 do? What is the variable head does? What's the purpose of the variable head? It keeps track of the points to the first node. Excellent, very good. So points to the first node. This is the, are you able to see the annotation on the screen? Okay. Okay, good. So nice. So head is not part of, we can think of head as, so yeah, head contains address head. So head is a variable. So this is a variable. It contains the address. It contains the address of the first element. It contains some address, and it contains the address of the first node in the list. And so what is present here? This is what is present here is null. If you see, let me, null, null pointer. That is, it's not pointing to anything. That is how we will get to know that we have reached the end of the list. All right. So now we have the code for line 12. It allocates memory to a node. What is the important point? Since we are allocating memory through malloc function, the memory gets allocated on the heap, and the lifetime of the node is of the chunk of memory that is allocated. It will be there until we free it using the function on line number 17 to 20. Until we explicitly free it, the memory that is allocated to malloc, it will be there on the heap. Of course, when the program execution ends, then everything will be released. Everything will be released after the program finishes execution. So now we are looking at the search node function. So what are we doing in the search node? So we start with C node is, so important point here. So C node is another variable. C node is another variable. So this is C node. C node is another variable. When we enter the for loop, C node points to C node points to the first. It points to the first node in the list. Okay, and this is done. We make C node point to the first node in the list by using this statement: C node is equal to head. And then we check if no, the key of the key that is present in this node is equal to the key that we are looking for. If it is present, that address we return. Otherwise, we move on to the next. So we keep changing the pointer of C node. So C node initially points to this, and then it points to the next node, and then it points to the next node, and then it points to the next node. And finally, it will point to, it becomes equal to null. When it becomes equal to null, we come out of this for loop. This is how the search node function works. Any questions in this program so far in the search node function? You're all good? Okay, I hope you are doing all right. So now let's revisit the delete node function. So where we are trying to delete so this is the code for delete node. See, when we are trying to traverse, when we are handling this delete node function, there is one thing I would like you to understand, to appreciate, that is the base case and the inductive case. So what is the base case? Let's look at the base case. So base case. Base case is when we start. So remember, so we have two variables. One is P node. P node is previous node, C node is current node. In the base case, what happens is P node is equal to null. It is equal to null. Yeah. P node holds null in the base case, and C node is equal to head. It points to the head. This is the base case. In the inductive case, this is the second inductive case is no. So P node points to, let's say if C node points to this node, P node points to the previous node. Okay, this is the inductive case. Case 2, this is inductive case. So we have to handle the base case and the inductive case slightly different. So if you see the code that we have written for delete node, case 1 is the base case that we are trying to handle. This is case 1, and this is case 2, inductive case. Is anyone unhappy with the code that I have written for the delete node? Is there any challenge or anything, scope for improvement that you see? Anything? Awake? Array is awake? Or awake arrays? Array is awake and rest not till you fix the linked list program. Some famous person. Huh? Vivekananda, Swami Vivekananda. Array is awake, rest not till you fix the linked list code. That is by me. Okay, so yeah. Hello, fellas, are you sleeping? Awake only, na? Okay, good. So the problem in this code is we are checking for case 1 again and again. So this case 1, the code on line 37 to 41, it will be true only in one case when we are trying to delete the first node. But we keep on checking it again and again and again and again. So there is an inefficiency because the line 37 to 41, it's not checking if priv node is equal to null again and again. So it's not a good idea. It's a performance problem. So what we would like to do, what I thought we can do is we can handle the base case outside the loop. Base case or case one, base case outside the loop. Let me do one thing. I want to use the same code for your next class also. I'll copy it. Okay, so what is the code for base case? The code for base case is Control X. Format. Why my format? Control Shift I is what we have to do, right? Okay. Are you with me now? Is it okay to do this one, taking the base case out? If and then yeah, if C node key is equal to key, and if priv node is equal to null, yeah, I don't do this check here actually, because when we do this one, so what do we do here? C node is equal to, actually I don't even need to, yeah. C node is equal to head, and yeah, so maybe we can just use this one. If head key, so if head key is equal to key, then what do we want to do? So yeah, it is better to use C node. Okay, let's use C node is equal to, there is one reason I have in mind. So you just check C node key is equal to key, and is the base case all right now? Are we fine with the base case? I will do Control Shift A from now on. Is the base case right? Does it make sense? Not make sense? Okay, I think it is okay. It's looking good. Line 34. Okay. And also I will use P node rather than priv node. Okay. So this is good. And how do we fix this code? Yeah. So now when we are coming here, what we have to do is P node is equal to so we should say P node is equal to C node. Yeah, so let me do one thing in order to make it clear. So when we are entering this, so C node, I want to make this code slightly clean. And with all these things, we can perhaps write the code like this. When we want to do the initialization outside, just so that the code looks clean, then inductive case. So what should we do here? If C node key is equal to key, then free C node and P node next is equal to C node next. No, here P node next is equal to C node next. Otherwise, we write the same code. So we are using two fingers here. Okay. Does this make sense for all of you? What we did here in the inductive case? We are iterating, we are using two fingers. So we are moving two fingers on the list. One finger points to C node, current node, and the other finger points to P node. Okay, P node acts as one finger, C node acts as another finger, and we keep moving. Okay, and this movement of fingers is corresponds to code on line 54 and line 55. Are you all with me here? And whenever there is a key that is available, then we have to remember we have to bypass. So we have to, when we are deleting, let's say this is the one which we want to delete. We want to make the next of this point to C node next and release this, free this one. Okay, so this is what we are doing on line 50 and line 51. Are you all good? Yeah, perhaps you may have more, Sri Teja has some interesting code, but this code makes sense. Are you all with me? Can I, is there any bug in it? It is looking good, all right? Okay. So now let's go to the insert node function. In insert node function also, we would like to do the same analysis we would like to do. Okay. So in the insert node, we want to do the base case versus inductive case. Okay. So now let's try to write the base case code here. So this is the base case code. For the time being, I'll comment this out. Okay. So this is the base case. And so what should we do if C node key, if it is less than or equal to, if it is greater than, if it is, let's say, duplicates are not there, or put it on another way, if the key that we are inserting, if it is less than the current thing, then the new node we have to, it will be at the beginning. Yes or no? The base case? The base case is when we are trying to insert something at the beginning. If you are trying to insert something at the beginning, then two things will happen, and then this next should point to this, and then head should point to this. These are the two things that we have to do in the base case. Okay, so yeah, so this happens when key is less than C node key. Okay, so it is at the beginning. So what should we do here? So we should allocate a node. So we should allocate a node. If C node is null, oh, good question, Amoga. Okay, so that's another, that is, let's call it as base -1 case. Base -1 case. I don't know whether there is anything like that. Base -1 case. If head is equal to null, so what should we do? So first of all, when we enter here, as soon as we enter this code, the first thing that we should do is we should allocate a node. We should allocate a node with yeah. So now I want to do one thing. I would like to see that we have allocate node written in this particular way. Does this make sense? Base -1 case is the one. Is the modification of allocate node all right? Okay, so now we have to just return node. Okay, so that's what we are doing. So now we want to allocate a node star. So let's call the node that we would like to insert as just n, or maybe capital N. Okay, so now capital N is equal to allocate node key. So you are good on line 35, right? We entered the insert node, we allocated a new node, and then we are checking if head is equal to null. If head is equal to null, what happens? Head should contain, head should equal to how key. What is that, Pawan? I just changed the code for allocate node, if you have noticed. Is base -1 case okay? Base -1 case, I hope all of you are with me on the base -1 case. And base case is when the linked list is not empty, and no, you look at C node is equal to head, key is less than C node. So how do we handle, what is the code here that we need to have? Base -1 case is when there is the list is empty. That's, we are inserting a node for the first time. That means head contains null pointer. What should be the code between 49 to 50? What is the code? Line 9, the base case, what is the code? Can someone tell me? I want simple code, okay? I don't want complex stuff. No, yours. And n next. Thank you, Bob. N next is equal to, head is equal to n, and n next is equal to, no, n next is equal to, it should be, C node is there. Okay. Okay, C node. N next is equal to C node. Great. And there is no freeing. Are you all with me on the base case? See, I really want you to pay attention to this one, because if you understand what is happening here when you do the data structures course, then you don't need to worry about the programming part. You can just focus on the algorithm part. If you don't know how to code this, then no, it becomes a challenge. When you go to data structures, you will see more complex algorithms, more complex data structures. But once you understand an algorithm or a data structure, coding it, it should not take time. Okay, and here we are taking a very simple data structure and we are seeing how we can write code for it. Line 50 also not needed. Okay, that's awesome. So in terms of the picture here, head n is equal to head, we are doing so this, okay, so 40, this is line 48 and this is line 49. This is what we are doing. Great. So now let's look at the inductive case. Inductive case, let's copy the code here. P node while C node is not equal to null. If key is less than C node key. So what should we do if key is less than C node key? Can you tell me the code for this one? What should I write here? So remember, this is the case where we are trying to insert something here. So this should now point to this. This should now point to this. Okay. So now can you help me out? So can I write P node next is equal to N? Can I write? Can I write P node next is equal to N? Hardik has, and N next is equal to C node. That's all. And C node N next is equal to N next is equal to not C node next. It is just C node. C node, right? Can someone clarify whether line 62 is right or? Okay, okay, awesome. Awesome, cool. Now we are good. And we continue this process. Let's say, is the story over? But let's say you, I would say there is, are all cases covered? Yeah, that is the case. So can we call it as inductive case plus one? Can we call inductive case plus one? It's a dumb name, but that is the case when the element that we are adding, it is not in between, it is present at the end. Okay, so if it is present at the end, what do we do? Let's say if we have to add a node here, then what's the story? What is the inductive case plus one? So what's the story if we have to handle? What code we should write? What will be P node? P node next is equal to N. That's all. We don't need to do anything. Does it make sense? Inductive case plus one. We don't need to do N next is equal to null, because when we are allocating a node, we are making it equal to null. So Ram Gopal, we don't need to do it. All happy? I hope you're all happy with completely. So that's all. So awesome. I hope you are, I'm just writing the code along with you so that you can see how to think and go about doing these things. Okay. Try to use diagrams, try to split it into cases and try to handle each of the cases separately. Okay. So now the whole code is done. Awesome. We are all, so sometime back we wrote one program with a terminal kind of interface. What is that thing? Do you remember the name of that program so that I can just copy? Student underscore DB. Huh? Oh, that is at home machine. Oh, for once I should have used GitHub and pushed stuff. Does anyone have that code, student underscore DB code, which you can copy paste so that I can quickly? Yeah, it's just A to I, some terminal. Okay. So something like this. Okay. So number one, I can write the code in few minutes, or maybe. Yeah, it's string sort 4.c print names. Yeah, I think yeah, it's okay. I can quickly. Srija has something. Let's see. It was integer bubble sort. Huh? Insertion sort. Bow pasted the code. Where is it? Oh, okay, okay. Not, yeah, not this one. Anyway, so we will do it. Don't worry. Okay. I just want to, we'll do it quickly. Percentage. Command. This becomes a little bit painful. Okay, let's, anyway, so let's do. I'm just looking at the code written by Bow. I'll just write it in few minutes. Time is 10:40. By 10:45 we will finish that. File start FP. Okay. Okay, so now we read a file and we have created the data structure, and all we are looking at is printf %. Yeah. Building a terminal interface for this one is slightly painful, but okay, we will do one thing. Let's do this. I got a brilliant idea. Let's see if it's brilliant or not. Okay. So this much we have. Let's compile this code and see what happens. GCC. What is this code? Linked insertion sort -G. Okay, so what all the things I have to do? Hash include stdlib.h. Int argc, the return type of main haunts us or haunts me. Let's print the list. Okay, okay. So I have an interesting idea. Oh, there is a print list program we have to write, right? Okay, okay. Good, good. That much we should do. Print void print list. Printf %d/n. What do we have here? C node key. Printf okay. So can you create, we'll create one file. So control S keys.txt. Okay, 10, 20, 30, -1, 0, 40, 22, 100, 88, 50. Keys.txt. /n has to be there somewhere. Okay, thank you. All good. So let's see .a.out keys.txt. Hey, nothing happened. So what should we do? gdb a.out keys.txt. Run. Run keys.txt. Okay, okay. So now what do? We will put a breakpoint on line number. So let's put a breakpoint on line number 134. Okay. We are on line number 34. Are you all with me so far? What we are doing? See, from GDB we called print list. Yay. So that's what I want to show you. I wanted to building an elaborate terminal interface is a painful thing in 5 minutes. So yeah, so now P insert key. So let's say we want to insert -100. Let's hope this is possible. P insert node. Okay, nice. So what do you think will happen now? -100. Awesome. I'm very happy. So this is a good way to debug your stuff. And let's say if you want to delete a node, delete node. Which node you want to delete? Let's say we want to delete 22. Okay, P delete 22. Again, P ins P print list. Okay, 22 is deleted. Cool. So yeah, that's our insertion sort program. We have -1 is there in the list before. Let's say if you add 200, that is at the end of the list. I'm not sure if I can directly call insert like this. Okay, P insert node 200. P print list. Yeah, 200 is added. -1 became 0, no? No. Did -1 become 0? No, right? It's there from the beginning. Scrolling up is pain. So what do you want, Ronak? Because scrolling up wouldn't quite work because what is missing? After deleting 22, -1 is there now. So it's not there before. Huh? No, I did. I know. I noticed it -1 actually. Oh, really? Now delete 20. Yeah? Let's now delete node 20. It could have been a visual glitch in the terminal. That's what I'm also thinking. Oh, I see now -1 has become 0. Became 0 again or not? I think this could be, it cannot be the case. Very interesting thing is happening. Ten, 30, 40, 50, 88, 100, 200, -100, 0, insert P, insert node. Some interesting stuff is happening. Whether it is because of oh, -1 is back. Huh? Huh. What is a glitch? You know, why is it? It could be the is it the case it's the GDB is doing some bug in GDB. I have an interesting problem here. When there is a bug in your program, is it a bug in your program? When there is a bug you see, is it a bug in the program or is it a bug in the compiler? Even 10 and 30 are missing in the print before insert 20. Oh, okay. Let's go back to the program. We are always right. Oh, I see this one, no? 40, 30, 88, some things are missing. But when we try in the program, no, we cannot control, do all this random stuff. Tell me what we should do here, because otherwise if you just print it, it will work. If you insert something, the previous printed list gets stuck, but they start missing right after we are done with it. List isn't getting connected properly. I'm seeing some interesting stuff going on. Try in VS Code debugger. I'm thinking some issue with the GDB. I'm just thinking that could be the case. But the only thing, okay, let's see. But the problem is I edit something and my GDB stopped working on VS Code. I had to set it up. Anyway, so very interesting. So I'm not sure what's going on, whether it is a GDB issue or there's a code issue or because if you just do print list here, you can, let's do one thing. So let's do, if I do print list, because we don't find all this inside cool stuff, no, weird stuff rather happening. You just so tell me what instructions you want to add and delete here so that no, you feel some. This is a list that we have. Okay, so -1 and 0 are there. This is the list that this is what we have here. Can you tell me, in order to do testing, what can we do? Delete node 22, and then "30" is missing in the keys. 30 is there, na? Everything, yeah. Okay, let's do. 2030. Yeah, I think maybe I am thinking some mischief is happening in the GDB. Yeah, that is my guess. Insert -10. Huh? Let's do insert 200. So, you know, this is interesting thing. That's why the area of software engineering testing, it's a huge area by itself. Delete -10. Okay, if this works, no, then I will leave it and think it's a GDB problem. So, okay, so shall we stop here for today? What do you say? We couldn't get to multi-file programming. I want to do a couple of things. I want you to do one interesting thing. Instead of, can you rewrite this code? And so that here, instead of key, we have char star name. Name is the key instead of, can you do that? Or we can have something like, no, we can have char star name and convert it into, this is unsigned long. Yeah, it's okay. I think we can just use char star name, and perhaps we can use int marks. Okay. Indians are so fascinated with marks, we can't think of anything except marks as a field. Dumb fellows, all of us. Okay, that's it. Enough. So can you try to do this? Aadhaar card is good, but no, sorting on Aadhaar card, it's not fun. It's not, doesn't make sense, or maybe make sense of whatever it is. Yeah. Okay, what do you say? You want to continue, or I think let's stop here, because I want to do multi-file programming properly for you in the next class. I wanted to see that these ideas are completely clear for you. Are you all with me today? In today's lecture, are you all with me? Everyone? I want to see that everyone is with me on today's lecture, because this sets up the base for everything that you do in your data structures course, what we did today. Yeah. So what I would like you to do is, yeah, on Tuesday class, on Tuesday's class, we will do multi-file programming, and we will use a tool called as Valgrind to do memory leakage analysis. Okay, that is also a very interesting thing to look at. We look at make files, we look at multi-file programming, we look at Valgrind, we look at some nice stuff in the Monday class, in the Tuesday class. Okay.